Okay. So in Algebra 2A, you guys did talk about inverses, right?
Yep.
So we're all somewhat familiar with what an inverse is. Anybody want to refresh our memories for us? What is an inverse exactly? Yeah? Okay. You got part of it. What do you do before you solve? Switch them, right? Whatever x and y are wherever they are in the equation, you switch them. An inverse is taking x and y and having them trade roles in the equation, and then you solve for the y after that. Okay, so a logarithm essentially is an inverse of an exponential. Those equations we've been looking at so far. So if I have let's say y equals 2 to the x is my exponential equation. And I want to do the inverse of y equals 2 to the x. The first step would be, like we said, to switch the x and the y. So then you get x equals 2 to the y. Okay? And then the process goes, okay, now solve it for y. And this is where we get stuck, right? How do you solve this thing for y? Well, the way that you solve an exponential for its exponent is basically just rewriting it in a way that's called a logarithm. Okay? So, the following two expressions or equations are basically the same thing. If x equals 2 to the y, then y equals log base 2 of x. Okay, so there isn't like a technique of like doing some kind of algebra to get it to there. It's just, okay, we're going to call this thing a logarithm and it looks like this. Now it's kind of a long story of why is it called a log and all of that, and I don't want to bore you with that, but if you are interested, I can share that with you later. But for today, I just wanted to focus on, okay, this is what it is, then how do we keep converting back and forth from one to the other? Okay? And I do want to make sure that you guys read these the right way, so I'm going to write underneath here how you would say it. Because I got students in my calc class that still get this wrong, so I want to kind of get you guys started the right way. So it's read log base 2 of. And really what I want to focus on here with you guys today, to start with at least, is give you an exponential equation, can you turn it into an equivalent log equation? Put things in the right place, okay? So the one thing that I always tell my students that tends to help in getting it from this to this is the base of the exponential is the base of the log. Okay, if you can remember that to start with. Now, let's see how the exponential has a base of 2. Okay, so base of 2, base of 2. It's just we write it in a different place. Okay, the base of the log is this little subscript that happens down here. Also, the point of writing out a log is to solve for whatever's up here. So when you write out a log, it's always equal to the exponent from this. Okay? So, I'm going to give you guys an exponential equation, and let's see if we can rewrite it as a log real quick here. So if I have 2 to the third equals 8. Now they're all numbers, there aren't any variables in there this time, but it's still an exponential type equation, right? 2 raised to the third power equals 8. So I can take that and write it as a log equation instead. So what would that look like then? So what's the base?
3.
Careful. What's the base? 2. Okay. So it's going to be log base 2. All right. And then what should it be equal to? 3, right? It's equal to the exponent. And the exponent in that first one was 3. And then the 8, what's left over, is what goes in the log. Right there. Okay? So 2 to the third equals 8. So 3 equals log base 2 of 8. That's how that one would switch. Okay, let's try one more, just to make sure we got it. So if we got 4 squared equals 16. Write that as a log equation. All right, somebody thinks they got it. Can you read it for us, what you have? Yeah?
Log base 4 is 16 equals 2.
Yep, that works. Okay, so we're going to practice a little bit more with this. I'm going to have you guys looking in your journals to do this. If you turn to page 164. And look at exploration number 1. All right, now if you want to use your calculator to help you with this, to like test some numbers out, that's fine. First thing you're going to be doing, though, in the directions there, it says, find the value of x in each exponential equation, explain your reasoning, then use the value of x to rewrite the exponential equation in its equivalent logarithmic form. Okay? So first thing we need to try is, can we figure out what x needs to be for each one of those? And like I said, you can use your calculator. It's kind of a little bit of a guess and check type of a thing. Okay, so common logs. Basically, a common log is any log with a base 10. So if you have like log base 10 of 3, that's a common log. But because they are common logs, we don't always have to write the base. So this is the same thing as just doing this. You guys remember when we were doing that little trick on your calculators? We're using the log button on your calculator, and that log button didn't have a little base on it because it's a common log. It's actually a log base 10. Okay? So let's do a common log by hand, and then we'll do it on the calculator again to verify the answer. Okay? And remember, it's a base 10. So let's see if we can calculate what is log of 1,000. What is the common log of 1,000? Well, doing it by hand, what was the technique we used? What was the process? Look back in your journal if you have to. What did we do by hand? That's what I was doing in the blue. Right, okay, so the first step before we did, you guys are right, but before we did that, the first thing that we did was we said, okay, let it equal x, and then try to pull it back into an exponential, okay? So for this, remember, even though I didn't write a little 10 down there, that's technically a base of 10. So it's going to be 10 to the x equals 1,000. And that's a problem I'm pretty sure we can all do in our heads. 3, right? 10 to the third is 1,000. Okay, so if you just type in your calculator log 1,000, enter, should get you 3. Should say 3. Right? Try it once if you haven't. Log 1,000 should be 3. So, this one, hey guys, this one you can do in your head, right? You don't need the calculator to do it. Now there are other ones where you will. Like if we had one that was, let's say I wanted to do log of 5. Okay? If I tried to do this same trick where I pulled it back into an exponential, in this case it would be 10. It's base 10. 10 to the x equals 5. 10 to what power equals 5? I don't know. I can't do that. It's some decimal. I'm not sure what it is exactly. But if you have a calculator and you can type in the log, you can certainly figure it out. Just type log 5, enter, and it'll give you an answer. And it's like 0.6 something or other. Okay? So log 5 is, 0.69897. Okay? So, sometimes you can do it by hand, sometimes you can't. In which case, just go to the calculator and you got it. And it's usually going to be some kind of a decimal or something like that if you can't do it in your head. Okay? So that's why those log buttons exist. Now, on your calculator, there is also another button right underneath log that is a natural log. Yep. And a natural log is a log with the base e. We were talking about e yesterday. So if I had something like log base e of 3, another way of writing that would be ln 3, or natural log 3. Now I know what you're thinking. Why is it ln? Why is it not NL, right? Natural log. Because the person that came up with this was French. And in French, it is the log naturel, or something like that. And so it actually goes the other way. So we use the ln for natural log, and it confuses all of us that speak English. But yeah, that's why. So, but basically just know that a natural log, the ln, is the same thing as having an e in the base. Okay? So, if I wanted to do like the natural log of 5, okay, it would be the same thing. If I was trying to do this by hand, I'd say, okay, make it equal to x. It's a base of e. So what would be the exponential then that would go with this one? E to the x power equals 5. So when you take this super long, crazy, irrational number, 2.71, blah, 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 that we talked about yesterday, and raise it to some power, it has to equal 5. Can you do that in your head? No, definitely not. But you have a calculator that can do that for you, and just by typing in natural log 5, and it'll give you the answer then. So natural log 5, so it would look like that. Natural log 5 is 1.609 something. So that exponent that would make this thing work is 1.609, etc. Okay. Now, believe it or not, there are some natural log questions you can do in your head. They have to be very specific, though. So, like if you had something you had the natural log of e squared. Okay, think about how you would do this. You would set it equal to x, right? And then try to turn it into an exponential. So it's always, think about how we did this one. Look at this example over here. What would it be over here? E to the what? E to the x equals e squared, right? Instead of 5, now it's e squared. What's the answer? 2, right? So they have to be set up like that, but there are some where you can actually still do it by hand and get an answer. So x is equal to 2 in that case. But yeah. So all right. So that's the common log. That's the natural log. Calculators are nice with those because you can just type them right in and get answers. And you get a couple of questions in your homework where that's all it is. It just says use your calculator to find the log of whatever, and you just type it in and you're done. There are some other ones. We're going to have to simplify some expressions. Oh, yeah, sorry. All right, and these are going to look kind of weird, but... So the first one, let's do 8. Like that. So it's 8 raised to the log base 8 of x. Okay, so yeah, it's a little confusing. So here's what we're going to do. We're going to make this thing equal to, I can't use x anymore, but I could use y. Haven't used that one yet. Let's say 8 to the log base 8 of x equals y. And even though there's a log in here, ultimately this is just one big exponential equation, right? Okay, so let's think about how we could move this thing back and make it a log equation using what we have here. Okay, so it would be log base 8, because of this 8 right here, right, of y equals the exponent. Well, what's the exponent? It's that big log thing that's up there, right? So you just write that whole thing out, that log base 8 of x. Well, what do you notice? X and y are what? Equal, right? Log base 8 of y equals log base 8 of x. Okay, well then, yeah, y just equals x. So what does that mean for our original expression we were trying to simplify? If y just equals x, y just equals x. So this whole thing right here is just what? X. That original expression we were looking at is just x. So we've got this property that we can use where whenever you have a log up in the exponent like that, as long as the bases are the same thing, in this case they're both 8s, they cancel. They cancel each other out. So the log in an exponential cancel. And it works the other way too, okay? So I'll just write the properties over here real quick. So if you have b, okay, b in this case was 8, but if you have b raised to the log base b of x, that always just comes out to x. So it's kind of like they're canceling each other out there. And then likewise, if you have an exponential that's been dropped into a log, so if it's log base b of b to the x, again, bases have to match, but if the exponential is in the log, they cancel each other out, and then what's that equal to, do you think? Just x again. Yeah. Okay. They look kind of weird, okay? But if you run across them, things cancel out, okay? So let's do a couple more of these and just kind of keep these at the ready, okay? And it really, these will get a lot easier, I promise. But I'm going to make them try to look like one of those two. Okay, so using those properties that we had up over here, see if you can evaluate each one of those by hand. So what's canceling out, what's left over for each one of those? I'll give you guys a couple minutes to do that. All right, do we need any more time or are we okay? Okay. What's the answer to number 2? 3, right? The 4s kind of cancel out. We're left with a 3. Okay. Number 3, remember a natural log is a base e, right? So that would just be 5. Yep. And the last one, that's a common log, but remember a common log is a base 10. So what's the answer to that one? -5, right. Okay, so they look weird, but if you can remember the bases cancel, then it's really not so bad. You can simplify it to something that's just a single number each time. Okay. Okay, I think I'm good there, and I'm going to let you guys get to your homework. I know we don't have a ton of time left. What do we got still? Got another like 15 minutes? Okay. All right. So we are on page 314. And what do we got? Let's do 5 through 23, 27. Oh, there you go. We'll go 35 through 41. And then yeah, that'll be good. All right, it's going to go away for just a minute because I'm turning off the recording, but it'll come back.